Hi guys, I'm making this video to help re-explain graphing over lines that are not horizontal or vertical because it always does confuse people. So one thing to review, this is on page 121 in your notes. When we were solving systems of equations, if your lines turned out to be parallel, if they weren't going to intersect or touch, then their slopes were the same. They were the exact. So if you found that a line had a slope of 2/5 and you wanted to be parallel to it, your slope would also have to be. But if you're trying to be perpendicular, that's not the case. Perpendicular means they intersect at a right angle. So back in the day when you were trying to prove whether something was, sorry about the bell, something was a parallelogram versus a rectangle, that's whenever you checked to see if you had opposite reciprocal slopes. Opposites meaning one number is positive and one number is negative. Reciprocal means you flip over your number as a fraction. So opposite reciprocal slopes. If you found a line that had a slope of 2/5 to be perpendicular to it, your slope would have to be negative 5/2. That way one's positive, one's negative, and one fraction is the flip of the other fraction. Sorry about the focusing issues. So when we did this, starting with the first one on number 8, you need to make sure the line is graphed, and it is, but you've got to find the slope of the line that's given to you. So I'm going to pick some nice points on this line, and I see that the slope is up 2 and right 3. The slope of this line is 2/3. We don't want to use the slope. We want to be at a right angle so that we can flip over just like we did when we did vertical and horizontal lines. So to be at a right angle, we need to have opposite reciprocal slopes. So I need the opposite reciprocal of 2/3, which means that number was positive. We will use a negative. This number was 2/3, so we will use negative 3/2. So we will start at our preimage point, which is A, down here in quadrant 3, and we will go to the line with a slope of negative 3/2. Now normally we'd think, well, go down 3, right 2. That's not going to help us hit the line. That's going to take us away from the line. So instead I'm going to try and go up and left, so we could think of this slope as positive 3 and negative 2. That way we can get to the line. So starting with point A, I'm going to count rise of 1, 2, 3, run of negative 2. And what do you know? After applying our slope exactly one time, I hit the line. And just like we used to count how far to get to the line when we reflected and how far to get away, we're going to do the same thing. Only now I'm just going to be counting, I used one slope to get to the line. Now I'm going to use one slope to get away from the line. So I'm going to then rise 1, 2, 3, and run negative 2. Again, we're just doing the exact same slope. So we can find that our image, A prime, lies at negative 5, 2. And if you would connect A prime to A, you'll see it passes through that middle point, that point that's in the center. It is the midpoint, and it hits at a right angle. If you end up having them cross at this weird angle like this, then it's not going to be right. It has to be perpendicular, which is why we use the slope of negative 3/2. I'm going to temporarily skip number 2 because it's complicated and it's not good to use as the second example. Let's look at the third example. Again, starting with the slope of the line given to us. So I'm going to find a nice point here, a nice point here, and I can tell that the slope between those points is negative 4/1, or just negative 4. I don't want to use that though. I want to be perpendicular to it. The number that is perpendicular, or the slope that is perpendicular to negative 4, is positive 1/4. So that negative 4 served its purpose. You're never going to use it again. You just need to use a 4. And I'm going to count. Well, if I go up 1 and right 4, it only took me one slope to get to my line. So I'm going to count and do one slope to get away from my line. So if I go up 1 and right 4, that would be the location of C prime. That way it took one slope application to get to the line, one slope to get away from it. This is the middle point because of that. C prime had to be located at 5, negative 1. So if we go back to the middle problem, I'm going to find the slope of my line first. There's lots of points you could use for this. I don't want to use that. Sorry. There are lots of points I could use. I'm going to use these two. And I noticed that it's a slope of down 1, right 1. The slope of the original line is negative 1/1, or just negative 1. But if you want to be perpendicular to that, you need to be positive, And the reciprocal of 1 over 1, well, it's 1 over 1. So we're going to use a slope of 1 over 1, which seems like, oh, that's not too complicated, not a big deal, until you actually go to apply it, because first of all, I can't go up and right because it's taking me away from the line. So I need to go down and left, which isn't a problem. That's something we've done before when we've graphed lines. But if I go down 1, left 1, I've done my slope 1 time and I haven't hit the line yet. So I'm going to do the slope again. Down 1, left 1. Well, I've done the slope twice now. I haven't hit the line. So I'm going to do the slope again. I'm going to go down 1 and I hit the line. It took 1, 2.5 slopes to get to the line. That's what makes this confusing. And you'll see those occasionally on IXLs too, that they make it a half of a slope to get there. But the thing is, we're just going to deal with being 2.5 slopes to get there. So we're going to go 2.5 slopes away. I'm going to do it the half first. So I did half on this side. I'm going to do the other half here. So basically, if I went down 1 to get to the line, I'm going to go away 1 first. So down 1, left 1, 1 slope. Down 1, left 1, 2 slopes. Down 1, half a slope. So I'm going to finish that half by going left 1. So half is not all we need to do. We need to do 1, 2.5. So we already took care of the half. Let's go down 1, left 1. There's a full slope. Down 1, left 1. There's my other full slope. So 1 and 1, those match. They're supposed to be mirrors because this is a reflection. There's 1 and 1, those match. And then if I go down, it's mirrored with going left. So this is why I skipped this one at first, because it's a little overly complicated. So then B prime lies at the point of -3, -5. So it's weird when you have to do half a slope. Usually it's the exact same amount to get to it, to get away from it. And it is always the same amount. I will tell you, you're only going to encounter that half slope scenario when your slope is either -1 or 1. You will never have that happen whenever you have like a 4 or a 2/5 or something like that. So just so you know, in those circumstances. Page 122 on your notes, now we're going to be finding the line of reflection. So preimage and image are already graphed. We just need to find what line did we flip over that made us go from here to here. So the first step at the top says find the midpoint of the image and the preimage, because we know it has to go halfway in between. So as a reminder, your midpoint formula from Unit 1 is when we averaged our x coordinates and averaged our y coordinates, meaning we added them up, divided by 2. We did that to both the y coordinates and first the x coordinates. So if I look, point P is at 5, 2. Sorry, P prime is at 5, 2. The preimage of P is at -1, 0. Well, of those numbers, -1 and 5 are x coordinates. So I'm going to add -1 plus 5. Well, -1 plus 5 is the number 4, and 4 divided by 2 is 2. I'm going to average now my y coordinates, 0 and 2. 0 plus 2 is 2, divided by 2 is 1. We now know that the midpoint is 2, 1. So our line of reflection that we're trying to create will also go through 2, 1. So, step 2, find the slope between the given image and preimage. You could use the slope formula here, but it's clearly graphed for us, so we could do it that way as well. I'm going to count from P to P prime. That's a rise of 2 and a run of 6. So the slope had a rise of 2 and a run of 6. But anytime you write a fraction, you need to reduce it. It actually has a slope of 1/3. And the interesting thing about that is if we hadn't gone from P to P prime, if we'd gone from P to midpoint, you would have noticed up 1 over 3, up 1 over 3. Not a coincidence. The fact that this is 1/3 and 1/3 is what we just did on the other side, where get one slope to go to the line, one slope to get away from the line. That has to happen. But when we go to write our equation, I'm not going to use 1/3. We need to be perpendicular to that line. And we said that perpendicular slopes are opposite reciprocals. Since this is a positive 1/3, we're going to use a negative, and I need the reciprocal of 1/3, so 3 over 1, or just -3. So to write an equation in slope-intercept form, you need a slope, which we have, and we need a y-intercept, which I don't know yet. But I know I have to pass through this point, so I'm just going to graph the line. I'm going to go down 3 and right 1. Well, haven't hit the y-axis yet. Down 3, right 1. I'm not about to hit the y-axis. So instead of going down and right, I'm going to do the opposite and go up and left. Haven't hit the y-axis yet, and it is inconvenient that this is going to go off our graph. But it's not too hard to figure out. 1, 2, 3 up and over puts you up at 7. So that would be our line of reflection, and its equation would be y equals -3, because that's the slope we have to use, the perpendicular slope. This 1/3 is done being used. It's not useful anymore. And we said it has a slope of -3 and a y-intercept of 7. So -3x plus 7 is the equation of that line. I'm going to jump to the second one again, kind of like on the front side. The second one is unfortunately more confusing than I'd like it to be. And I want to show you that we could actually skip finding the midpoint with the midpoint formula by just doing what we've noticed about the slope relationship. So if I count rise, I see a rise of 4, or you could have done -4 depending on which point you're starting with. But if I go up 4 and then I count over, I'm seeing that I'm rising 4 and running -8. The slope between my image and preimage is -4/8, which reduces to -1/2. So if I want to skip the midpoint, I just need to figure out how many slopes does it take me to get from here to here, because I want half of that. Meaning I could go down 1 and right 2. Well, that sure doesn't look like the middle, but I'm going to do it on this side. Up 1 and left 2. My points haven't met yet. Down 1, right 2. Up 1, left 2. This is the point that would be the middle, because we would do 1 slope, 2 slope, or from this side, 1 slope, 2 slope. If it takes 2 slopes to get to this point, no matter which one you start from, that is the midpoint. And if what I'm saying is super confusing, don't do it that way. We have the midpoint formula. There's no reason that you have to do what I just did to find this number. The nice thing about doing it this way, once you know you're going to pass through this point, you can go ahead and graph your line, because you know you have to be perpendicular to -1/2. So the perpendicular slope to -1/2 is +2/1. So when I go to graph my line, I go 2/1 from my midpoint, or down 2/1, down 2/1. When we go to write the equation of that line, you need the slope and the y-intercept, and we have that. As a reminder, it's not this slope. This slope helped you find this number, and that's all it does. Well, and it helped us find the midpoint. But yeah, we're done with it. This is the slope we need. So that line that we just drew has a slope of 2 and a y-intercept of 1. I'm not going to go back and do the second example. It's overly complicated, and I can tell you you're not going to have any on an assessment that gets that complicated. So rather than spend time potentially confusing you on it, we're just not going to do it. So good luck.